So this is Polynomials Lesson 1, just an introduction to polynomials. So let me show you some examples of polynomials. 3x squared minus 2x plus 1, 2x plus 3, 3x, 4.56x cubed plus 3.12x minus 7, 3/4x squared minus 2/3 x plus 12/13. So it may be easier to see, well, what's not a polynomial then? So 4x to the negative 1 plus 2x minus 1, not a polynomial. How about 3 over x plus 2x plus 7? That's not a polynomial. Again, what's violating this time? So in this first one, is negative 1. So polynomials do not have negative exponents like this. How about the second one? This x. Polynomials we do not end up dividing through by an x. This is in general. So 4 minus x over 2x plus 9. Again, this is not a polynomial. We have an x in the denominator, which usually rules it out. Now if we can somehow remove that part, we can sometimes make it look like a polynomial, but we're not going to get into that. How about 3 square root of x minus 7x plus 1? Not a polynomial. The square root here messes us up. 3x to the 1/3 plus 7x minus 2. Again, that messes us up. So in general, polynomials, we looked at some characteristics of these right before, and our exponents are nice natural numbers. So the exponents on the variables are like 1, 2, 3, 4. I'm not dividing by x's. I don't have square roots around the x. This is actually a fractional exponent in disguise. And if I were to graph a polynomial, it would be a nice smooth curve. So polynomials have curves that look like this. And they just keep going on. Non-polynomials have curves that look like this. They have breaks in the graph. They have these things called asymptotes that go all over the place. So we have to be careful with that. So just some vocabulary terms. So if we want to list the terms of 5x cubed plus 3x squared minus 7, the terms are separated by a plus or a minus. So simply put, the terms are 5x cubed, 3x squared, and a negative 7. Those are the terms. We can classify polynomials into the number of terms they have. So a polynomial is one term, called a monomial. So mono meaning one. Binomial, 2 terms. Trinomial, 3 terms. And we don't have a word, a special word when there are more than 3 terms. So just some parts of the polynomial. So let's just look at this part here. So this is called the coefficient, the number that's written beside the variable, coefficient. The exponent on that variable is often called the degree when we're talking about polynomials. So this would be a polynomial of degree 2, or a second degree polynomial. Also, this is a monomial, right? One term. Second degree monomial. So let's practice with this. Example 1. So find the coefficient and degree of the following. So 3x squared. Coefficient 3, degree 2. Pause the video, write the other ones. At least go through the mental exercise of doing it. Alright, welcome back. Coefficient 4.2, degree 3. 2/3 x to the 4th. Coefficient is the 2/3, degree is the 4. Coefficient here is the 4. Degree, what's the degree? It's 0, right? This is x to the 0 is what? 1. So this term's not there. Example 2. So now find the leading term. So we got a new word here: leading term, leading coefficient, and the degree of the whole polynomial. So what does this mean? So the leading term is negative 3x to the 5th. So the leading term is the term that has the highest degree. Now often these polynomials are written in descending order, so that is often the first term. And when you write your final answer, generally will be that way. But the leading term is the term with the highest degree. So we look through here, the highest degree is 5. It beats out the 2 and the 1 and the 0. The leading coefficient is the coefficient of the leading term. So you find the leading term, you got its coefficient. Oop, I missed that. That should be a -3. And the degree of the polynomial is the degree of the leading term. It's the term that has the highest degree, and that degree of the term with the highest degree. So it's easier to say just the degree of the leading term. 5. Fifth degree polynomial. We look at all the degrees, all the exponents. The highest one is the degree of the polynomial. Why? Well, the highest one sort of dictates the behavior of the polynomial. Because after a while, with big numbers that I put in for x, these other terms actually won't even matter. They'll be insignificant. And we'll see that when we start graphing them. So let's complete the table for the polynomial. This is sort of a standard question. 4x squared minus 3x to the fourth plus 2x minus 1. So let's list out all the terms, and then we'll list the coefficients for each of the terms, we'll list the degree for each of the terms, and finally the degree of the whole polynomial. Pause the video here. If you can do this one, you'll have understood, you'll have sort of proven understanding of the last couple examples we've done. All right, welcome back. So we list out each term. 4x squared, negative 3x to the fourth, 2x, and I'm leaving out my negatives. That should be a -1. I did this on the airplane, so it easily missed a couple things here. Hopefully I'll catch them. Coefficients. Again, I left out my negative there. So 4, -3, 2, and -1. And the degree of each term. So again, we're looking at the exponents. Second degree, fourth degree, understood 1 there, first degree, and there's nothing there, so that's a 0. The degree of the polynomial, we're basically look at each of these values here, and the highest one ends up being my degree of the whole polynomial. Combining like terms, we've talked about this before, but let's now sort of formalize it with polynomials. We can combine like terms if they have the same degree with the same variables. So for instance, in part A, what can I combine here? I have 3x squared plus 2x squared plus 4x minus 2. So same degree with the same variable. I can combine 3x squared and 2x squared to get 5x squared. And 4x minus 2, nope, so it's just plus 4x minus 2. Now if that were 4x minus 2x, I could combine them, but it's not. So this is it. See what you can do on B. Alright, welcome back. You have an option here. I'll leave it up to you. It's sometimes easier for students if they will rewrite the like terms beside each other. You don't have to, but I'm going to do it here just so you can see what I mean. So 4x cubed plus 3x squared plus 2x plus x. I just wrote them side by side. This gets more important if you got more than just 4 terms and also you have minuses throughout. It can get a little tricky. So 4 and 3 is 7. Oop, this should be 3x cubed. 7x cubed plus 3x. Example 4. Let's combine like terms. Again, we typically rewrite our final answer in descending order, highest degree to lowest degree. So let's identify our like terms, 4y squared and 2y squared. Then we have a y term, and then this number here is not going to be combined with anything. So I'm going to rewrite these terms side by side. So 4y squared plus 2y squared, and then put the -1/2 y and the plus 3/2 y together. Now I can combine my like terms, right? So I've got the 4y squared, 2y squared gives me the 6y squared, and the -1/2 y plus 3/2 y is just a plain old 1y plus 1. Yes, you can have a 1 there, and that'd be fine. I typically don't write it though. Evaluating polynomials. Again, we've kind of done this before in a different format. We called them formulas. When we had formulas and I told you to put some values in, this is really all we're doing here. So let's evaluate the polynomial y equals 2x cubed plus 4x minus 1 at x equals 2 and at x equals -2. So two different problems here. So x equals 2, let's pop it in. So again, the 2 is just going to go in wherever we see the x. So 2 times 2 cubed plus 4 times 2 minus 1. Hopefully I did the arithmetic right. So 2 cubed is 8 times 2. This should be 16 plus 8 minus 1. Now let's combine some like terms. So 16 plus 8 is 24 minus 1. It should be 23. I'm going to blame the airplane on that mistake. 23. How about the next one? So see if you can plug in a negative 2. So you just plug in a negative 2. You get a negative 16 minus 8 minus 1. Careful with the negatives, right? When I have negative 2 cubed, that's going to be a negative 8. Times 2 is a negative 16. Now combine your like terms, you'll get a negative 25. Okay, fine. P of negative 3. So now we're just utilizing our function notation. We learned in an earlier lesson. P of negative 3 means that I'm going to plug in a negative 3 wherever I see an x. So P of negative 3 is 2 times negative 3 cubed minus 3 times negative 3 squared plus 4. Just be careful here if you're evaluating by hand that you pay attention to your negatives. So negative 3 cubed is negative 27. Negative 3 squared is a positive 9, so make sure you make that sign change. Now just do some arithmetic, combine the like terms, you should get negative 77. So a couple different ways we can evaluate this on the calculator. We can just do it straight up. We can say 2 parentheses negative 3 cubed minus 3 times negative 3 squared plus 4. Oh, I've got it inside of notation still. Mode, we'll put it at the normal, we'll put it back out to float. And press enter again, we get negative 77, that looks good. A couple other ways we can evaluate this, but I will show you those in class or in another video. I don't want to clog up this video. It's just a bunch of different ways to plug in these values. Quickly, you can use the store command to store negative 3 in for x. This is nice if you've got a much bigger expression. You can use the graphing window here to do it. You can put in the 2x cubed minus 3x squared plus 4 in here and actually evaluate the negative 3 there. But we'll look at that in class, or if you're not in a class, then I'll show you other videos on how to do that if you want to see it.